So finding possible angle measures includes previous topics such as the unit circle and reference angles. Now, if we had something along the lines of the information saying sine of some angle equals a half. Now, you can find the measure of the angle by taking the inverse sine of both sides and say that theta is the arc sine of 1/2. Therefore, we get an angle measure of 30 degrees. So now, 30 degrees is a first quadrant angle. But this information here says that sine is a half. If you go back to the unit circle, then the y value is a half in two locations. Don't think of this as sine is a half. Think of this as sine is positive. Okay, 1/2 is a positive number, which means we might be in the first quadrant or the second quadrant. So 30 degrees is simply a reference angle. Which means we can have a measure of 30 degrees that lies in either the first quadrant or the second quadrant. So we have a possible angle measure of 30 degrees or a reference angle of 30 degrees into the second quadrant. So the x-axis is 180 degrees, and 30 degrees before that is 150. So we have two possible angle measures for the value sine theta equals a half. Now, if we had more information, we could have restricted this to either 30 or 150. So if we have something, let's say we have the point 3, -4, lies on the terminal side of theta. This is telling you what quadrant you're in. The point 3, -4 is in the third quadrant, so let's draw that in standard position. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Let's sketch the position 3, -4. Now notice that that lies outside of the unit circle. So if we were to draw that, we would have a point over here somewhere. Excuse me, fourth quadrant. So 3, -4 is in the fourth quadrant. We sketch this as an angle rotation. There's the terminal side of theta, and this is our reference angle right there. Remember, reference angles between the x-axis. So now we have a right triangle in the third quadrant in which we have two legs of the triangle. This distance is 3 in an x direction. This distance is -4 in a y direction. And this distance here, if we use the Pythagorean theorem, is 3/5. So what we can do here, we can find all trig function values. We can find the value of sine. We can find the value of cosine. We can find the value of tangent. We can find the value of cotangent, secant, and cosecant using all of this information. So we have all three sides of the right triangle. This question will read something along the lines of what is the value of secant theta? Well, we can find all trig function values, but if the question said secant, obviously you would simply find the value of cosine and take the reciprocal. But if we wanted to find sine theta, cosine theta, tangent theta, secant theta, cosecant theta, and cotangent theta, now we just have to use SOHCAHTOA for this right triangle. So now, just to review really quick what we did here, we had the point 3, -4 on the terminal side of theta. The point 3, -4 lies in the fourth quadrant, which told me I have a fourth quadrant reference angle. So I made the hypotenuse look like an angle of rotation. And then I just said, well, in order to get here, I had to go over 3 units and down 4 units. So we have two legs of a right triangle, use the Pythagorean theorem to find the last. And now we can find all trig function values by using SOHCAHTOA. Sine is opposite over hypotenuse, -4/5. Cosine is adjacent over hypotenuse, 3/5. And tangent is opposite over adjacent, so -4/3. Secant is the reciprocal of cosine. Cosine is 3/5. So secant is 5/3, so that would have answered this question, but we're going to find all trig function values. Cosecant is the reciprocal of sine. So this is 5 over negative 4. Cotangent is the reciprocal of tangent. So cotangent is 3 over negative 4. So now let's look at all this information and compare this to all students take class. We're in the fourth quadrant, so the only thing that should be positive is cosine. The reason this is negative over here is because we were moving down in a y direction. The reason this is positive over here is because we were moving right in an x direction, which are positive and negative directions. Sine is negative 4 over 5. Fourth quadrant, it should be negative. We're moving down. Cosine of 3 over 5, it's positive. It should be positive. We're moving right, and cosine is x. Tangent is negative. Yep, should be. Cosine is the only one that should be positive. Secant is positive. Well, that makes sense because cosine is positive. Cosecant is negative, and cotangent is negative. So our picture makes complete sense because it satisfies all students take class. Let's say we had something that said cosine theta equals negative radical 3 over 2, and sine theta is negative. What is the measure of theta? Okay, so this is giving us a couple of conditions here. This is giving us a value of cosine. It's giving the x value in the angle of rotation, and it's also telling you that sine is negative. Regardless of cosine's value, cosine is a negative number. So let's first find out what quadrant we're in. Well, if cosine is negative, that means we're in quadrant 2 or quadrant 3. If cosine is negative, that means the x value is negative. But sine is also negative. So we have to be in the third quadrant. So since cosine is negative and sine is negative, we're working with a third quadrant value. So let's find a reference angle by taking the inverse cosine of negative radical 3 over 2. Theta equals the arc cosine of negative radical 3 over 2. So if you use your calculator here and take the arc cosine of negative radical 3 over 2, that's going to give you a second quadrant angle. If you take the arc cosine of negative 3 over 2 in your calculator, you should get 150 degrees. Well, that doesn't make much sense because that's a second quadrant angle. What the calculator is doing is giving you the first angle which satisfies negative radical 3 over 2. So let's draw the angle that we got with our calculator. The angle we got was 150 degrees. But because sine's negative, this doesn't make much sense. We should be in the third quadrant. Let's find the reference angle and put it into the appropriate quadrant. Well, the reference angle would be 30 degrees. So that's what we're going to put down into the third quadrant. The calculator doesn't know which quadrant we're in. All the calculator knows is that cosine is negative. So it gave you a second quadrant value, which means we can find a reference angle and put it into the appropriate quadrant. So we're going to put 30 degrees into the third quadrant. Well, the x-axis is 180 degrees, and we're 30 degrees past that. Therefore, we have a value of 210 degrees. So just to summarize, when you take the inverse sine, the inverse cosine, or the inverse tangent, that will most likely be a reference angle. You have to determine which quadrant your reference angle should be in with all of the given information. And the way you do that is with all students take class. So reference angles can be in any of the 4 quadrants. Make sure your information makes sense.